This is the JOMC 161 lecture on web and print graphic optimization. Probably the first thing you're going to want to pay attention to is your file formats. Now, if you're going to be printing a file, or if you're working on a file in Photoshop, you're most likely going to be using a PSD, which is a Photoshop native document. Now, PSDs are all bitmapped, which means they're pixel-based or raster. And the beautiful thing about PSDs is that they support layers. So here's an example of an image that's layered. What Photoshop does is it allows you to bring in different elements of the image on different layers and simply overlay them. They can interact with each other, or they can simply just sit on top of each other, and those composited create your whole image. Another format that you may run into is a BMP, which is simply a bitmapped image. You may encounter TIFFs, which is another form of flattened bitmapped images. TIFF stands for tagged image file format. PICT or PICT with an I. PICs are an original Apple file format for graphics. They're not very commonly used anymore. PNGs are kind of interesting because they're the only file format for graphics that's cross-compatible between print and the web. PNG stands for Portable Network Graphic. The reason they can work for print files as well as web files is that they are a lossless compression. They don't throw away data, and we'll talk about lossy and lossless compression in a bit too. The other thing that PNGs do is support an alpha channel. So here's an example of something with an alpha channel. The alpha channel gives it transparency. So we'd use an alpha channel to create transparency in an element. And Photoshop, of course, supports that fully in all of its layers. Then the last print file format, and probably the one most recommended, at least by me, is a PDF. And the reason I recommend it is because it is compatible with a variety of systems. Just about anybody has Acrobat on their computer and can open and view a PDF. The other reason PDFs are so good is because they support multiple types of files within one document. You can have fonts, you can have raster images, you can have vector images, and you can have all of these things collected into one single document in that PDF. And so that makes it a very useful type of document. Now, the web file formats are a little more limited. You're probably familiar with JPEGs, Joint Photographic Experts Group, and it can be spelled JPG or JPEG. It doesn't really matter. The nice thing about JPEGs is when you use JPEG, it's a high compression, and it makes a very small file. So your images on the web will download quickly. The smaller your file is, the faster it downloads. The compression that it uses is called lossy compression. And what that means is essentially the computer or Photoshop or whatever you're saving with goes through the file and finds information, colors, and detail that are simply, the computer says, well, this is too small or too insignificant for the human eye to see, and just throws it out. So it throws out information, discards information from that file in order to make it smaller. Now, ordinarily, the computer is right, and you wouldn't see that change in the image visually. But if you do it too many times, then you can start to see degraded image because it throws it away every time. The next slide will talk about compression more specifically. So JPEGs are most commonly used for photographs on the web. Anything that's a picture or anything that's really got detail or that has, it doesn't have like solid lines like a logo. And speaking of logos, GIF, or some people call it GIF, the oldest web file format, stands for Graphics Interchange Format. And this is the format that supports things like a logo. So the academic N, which is a solid color logo, it's got hard edges. It may need transparency, and GIF supports 8-bit transparency. 8-bit transparency means the pixels are either transparent 100% or opaque 100%. There's no middle ground. One of the other nice things about a GIF is you have a selectable color palette, so you can actually choose which colors appear in your image and which colors do not. So you can kind of limit that color palette specifically to avoid modeling of color in your solid color areas, which you may see in a JPEG or multiple colors. The other thing GIFs are good for is icons, logos, stuff like that, because GIFs typically make a very small file. Now there's a lot of research been done into image compression and comparison between GIF and PNG and GIF and JPEG. And there are certain types of images that work better in one versus the other. But for now, we'll just kind of stick with the concept that if your image has a lot of solid color, there's not a lot of detail, no gradients, and you may need transparency, particularly for a logo or an icon, you're going to want to use a GIF. Then, of course, we've talked about PNG, the portable network graphic. It is a lossless compression that supports alpha channels, so an image like this, a dice, and those of you familiar with Photoshop will recognize the checkerboard pattern means transparency, which means once I save it out, it's going to look more like the image of the girl with transparent edges. And then our last file format that we're going to talk about is SVG, which is a scalable vector graphic. And here's a couple examples of that down here. The beauty of scalable vector graphics, and they are growing in popularity on the web, is that you can resize them. Infinitely scalable is what we call it. They're infinitely scalable, and you will still have good high quality resolution, because the images are not based on pixels. They're based on mathematical equations and vectors and shapes. And we've worked a little bit with that in Illustrator. And so those are useful for when you want this image, when you don't know how large it's going to be displayed, you want to make sure that it looks good at any size. So just a real quick note about compression. There is lossy compression, which the benefit of which is it creates small files. The downside is that it is, because it discards information, that's how it creates the smaller files. It discards data from that image file. And that compression, that discarding of information, is cumulative. So every time you resave and recompress that file, you're throwing away more information. And eventually you're going to find that you will actually see a difference in the image. You're going to have degradation in the image quality, and you're going to start actually seeing missing information. And it's not going to look good. Lossless compression is the other end of the spectrum. Does not discard information. The downside is that it creates larger file sizes. And here's that compression study that I talked about, comparing GIF and JPEG and PNG files. And I'll put that link in so you can access that to take a look. So color spaces, when we're dealing with print and web, we're dealing with different color spaces. On the web side of things, we're dealing with what we call additive color. And that uses a red, green, and blue RGB color space. Additive color is created using light. And then on the print side, we have subtractive color. Subtractive colors are created using pigments or inks. And the primary colors of subtractive are cyan, magenta, yellow, and technically black, because you cannot technically mix all three of these colors to create a black. It's called subtractive color because each color absorbs a light, and so as you mix the colors together, it subtracts more light, and if you mix all of the colors together, it's subtracting all the light, which creates your black. Additive color is the opposite, so the more colors you add, the fewer colors are absorbed, and if you add all the colors together, you end up with white light. The RGB and CMYK spectrums next to each other, you'll note that the CMYK spectrum is much more muted than RGB. RGB has a wider color gamut, so it can display brighter, more brilliant colors than CMYK. Within the print color space of subtractive, you have a couple different options. You have what's called CMYK process color. That is using the primary colors, cyan, magenta, yellow, and black, mixing them because they're transparent colors, mixing them and printing them together to create all of the colors within the CMYK spectrum. The second type of color that you may end up working with is called spot color. And spot color is not a combination of the CMYK colors to make a color. Spot color is one specific color that's laid down on its own as its own color. And Pantone has gone to a lot of trouble to sort of market those spot colors. In Pantone, you can find they're color booklets. Basically, they're just basically booklets of all the colors you can buy, all the spot colors you can buy for a printing press. And they're real kind of fun to have. But spot color and CMYK process color are the two main color spaces and the two main types of color that you'll use when you're printing. On the web, you're going to be using RGB. And there's a couple ways you can identify colors on the web. Obviously, you're not working with ink, and so you're using codes to define a color. There are hex codes, which are those 6-digit hexadecimal codes. A4C400 is going to give you lime green. They're always preceded by the hashtag, so that's how you identify a color on the web. The other way you can do it is through the RGB code. So the RGB code has 3 sets of numbers that identify the red values, the green value, and the blue value in a color. And so every color has a specific hex code and a specific RGB value associated with it. When dealing with resolution for print, you typically want to make sure you're working in dots per inch, DPI, as opposed to PPI, which we'll talk about. PPI stands for pixels per inch, and DPI stands for dots per inch. And obviously, the lower the DPI, the lower the resolution of your image. The higher DPI, the higher resolution, the cleaner the image and more detail the image is going to have. Your DPI is kind of based on your printer resolution, the number of dots that your printer can lay down in 1 inch of a substrate, whether it's paper or material, t-shirt material, whatever it is. That is what your DPI of the printer is. And so basically, when you're going to export an image for a print job, you kind of have to know what the resolution of your output device is going to be. Most things like magazines are printed somewhere around 180 DPI. High quality magazines, things like National Geographic, would be printed somewhere closer to 300 DPI. Just regular everyday People magazine and those kinds of things are 180 DPI. Sometimes 150 depending on the quality of the magazine. When you're talking about print resolution, you're more concerned with resolution and the physical image. And in Photoshop, I'm going to open Photoshop in a minute here, and we'll take a look at exactly what that is. When you're dealing with image resolution for the web, it's kind of a different story. The mindset has really been that 72 pixels per inch is the standard for web, and it's kind of everybody just goes with it. But in reality, monitors are usually a little higher or much higher quality than 72. I mean, you look at, here's a little comparison between last generation MacBook Pro screen and Retina display MacBook Pro screen. You can see there's a significant difference in the number of pixels per inch displayed. And in fact, some of the Retina displays, iPhone, iPad, and some of those can have resolutions up and above 220 pixels per inch. Now that's considerably more than 72. So why are we still kind of dealing with this mindset that 72 pixels per inch is the standard? I'm not really sure. But the key is when you're dealing and you're looking at resolution of your image for web, you want to look at pixel dimensions, not resolution. Pixel dimensions are the number of pixels that your image is wide. Here's an example of what Photoshop has for image size. And let's just actually go directly to Photoshop. We'll take a look at Photoshop. So we've gone into Photoshop now, and we want to take a look at what the pixel dimensions versus the actual print resolution dimensions are on this image. So if I pull up that image size window, you can see that my pixel dimensions at the top are 1680 by 1050. And that's what I'm going to look at when I'm looking for my web resolution. Down here in the second box, I have document size. So this is what I'm looking at if it's going to be printed. So if I'm printing this, my resolution is going to be 300 pixels per inch, and my actual printed size is going to be 5.6 inches by 3.5 inches. It's not real big, but if we go back up to look at the pixel dimensions, that makes sense because there's not really that many pixels in the width or the height. 1680 pixels from one side to the other is not actually that big. So what we can do is, if I'm going to be printing this, I probably want to leave this at least 180 pixels. And if I change my resolution to 180, you'll see that my print size actually goes up to 9 by 6. But my pixel dimensions don't change because I've turned off resample image. If I want to change the size for the web, I come up here and I actually want to define how wide that image is in pixels. And for this, I need to know what my web dimensions are going to be. So for instance, I'm going to say, well, my website is 1200 pixels wide. I want this to be about half, so that's about 600 pixels. So I'm going to make this maybe 700 pixels just to be on the safe side. So my width is going to be 700 pixels. And you can see up here at the top beside pixel dimensions, my original image size was 5 megabytes. Now I've dropped it down to 897 megabytes. I've also dropped my document size. If I were to print this now, it would print at 2 inches by 1.5. But I'm not really concerned with that when I'm dealing with web graphics, because what my main concern is obviously is how many pixels wide is it. So then I click OK. It resizes the image. Now that is the actual size that the image is going to look like on the web, on this screen. If I were to look at this on a different monitor with a higher resolution, it might look smaller. Let's take another image. Let's take a look at this image. Now this image is a much higher resolution. This image also has an alpha channel, so you can see the transparency here. And what I want to do is I want to save this image as something and maintain that transparency. So first thing I want to do is I want to take a look at my pixel dimensions. If I'm going to be saving this for web, my pixel dimensions are 2400 by 1734. That's pretty big. My actual file size is 11.9 megabytes. That's way too big to be downloading really quickly on a website. So obviously I'm going to have to make it smaller, and obviously I'm probably going to have to compress it. If I were to print this image, this would print at 300 pixels per inch. It would print 8 inches by almost 6 inches. If I were to drop this down to 180 pixels per inch, turn off resampling, then I would jump my document size jumps up to 13 inches by almost 10 inches. I'm not going to print this one at this point. I want to make this an image on my website. So maybe we take this one. We say, okay, this one is going to be 600 pixels wide. It's going to be half the width of my web page. Then you can see the same sort of thing happens. My document size shrinks. My file size is going to shrink, and if I click OK, my actual image is going to visibly shrink. And if I look at it at 100%, that's the size it's going to be on my website. So, okay. So next step I want to make sure to look at my color space. If I'm going to print this image mode, I can change it to CMYK color. Now, if you're going to be printing on like a desktop printer or something, most of those have built-in RGB converters. You don't need to convert to CMYK first. But if you're going to send this to a press or a professional printer, they may prefer, and you will need to know by talking with them what they prefer, but they may prefer a CMYK color space document. I mean, they may accept RGB and they'll charge you to convert it themselves. So I can convert this to CMYK. Now I am a CMYK document. You can see up here on the very top of my document, my tab, now it says CMYK. I'm going to print this. That's what I want to do. Obviously, I've resized it already to a web resolution or a web size, so I don't really want to print it. So I'm going to undo that. Now I'm back to RGB. You can see my RGB up here in the top right, and the little 8 beside it is actually an 8 bits, 8 bits per channel, that's fine. That's what I want. So my next step is to save it, and Photoshop has a save for web. Save for web brings up 2 windows. Well, I can change it to 4, but we'll stick with 2. on the left I have my original, and on the right I have my optimized. Now my optimized right now doesn't have any transparency. And the reason for that is because it's set to JPEG. If I want to keep the transparency, I'm going to have to do one of two things. I'm going to have to choose a GIF. And if I do that, you can start to see, let me zoom in here, the GIF does some really ugly things to my image. And I don't really want to do that. So maybe what I need to do is, let's zoom back out a little bit, is take a look at doing a PNG. So PNG 8 gives me transparency, but I don't have the right colors that I want. I'm not sure that that's exactly what I want. So maybe I need to do PNG 24. 8-bit versus 24-bit. So I change this. Oh, there we go. Now I've got transparency, and it looks a lot like my original. In fact, I really can't tell visibly. Visually, looking at this, I really can't tell a difference between the original and my output. I've also gone, if I look down here in the bottom left of each of these window tags, or window sections, I've gone from 1000K to 483K, which at typical cable modem speed is 11 seconds download. That's still pretty large, but I'm including transparency. It's a trade-off between file size and options like transparency and quality. So once I've decided what I want to do, I click Save, I name it, and I save it into my images folder. I can do the same thing with the second image here. I've already sized it. I can go into Save for Web. Now I don't need any transparency, so here's where I can change this to a JPEG. And I have quality settings. So what we can do is I'll bring up 4-up tabs, and we'll take a look at a low quality setting, a medium quality setting, and a high quality setting. And then we'll zoom in on it and see if we notice a difference. We probably will. Once I zoom in on this, I can see that my low quality setting adds a lot of JPEG artifacting. My medium quality setting still adds some. Even my high quality setting adds a little bit. So what I'm going to do is maybe go in and do a very high quality setting. And now I don't see much difference. There's a slight difference, but there's actually, when I zoom back out, there's actually not enough difference to make it visibly obvious. And in fact, I probably can't see a difference between my high quality, which is a 60% quality, versus my 80% quality, which is very high. So the key is to choose, okay, I've got a 70K smaller file, and I really can't see a difference between these two. So I'm actually going to choose my high quality over the very high quality. And I can say here, well, I have the option at this point to make sure that my size is what I want. So maybe at this point I've decided I don't need 700 pixels wide, I just need 600. So I can change that here. That will resize my image right in this window, and then it'll give me a new reflection of what that image size is going to be. So 80K, that's not bad. So I click Save, I name it, I save it, and I'm pretty much done with that. Let's take a look then at Illustrator. So in Illustrator I have created an icon. And this is all sort of vector elements, except for I've got an image stuck in the background. But I want to save this as a little button. There is no image size in Illustrator. I'm basically dealing with image size when I'm actually doing my output. I can mess with the color space. If I go under File, Document, Color Mode, I can change it to RGB or CMYK. I'm going to be using this on the web, so I need RGB. My next step would be to save it. So there is a Save for Web in Illustrator as well as Photoshop. It's similar, but it looks a little bit different. We only have a 2-up option, so I'm looking at my original and then my output one. And so here I have the option to do a GIF, and you can can see it starts adding some weird whiteness to the outside. I can do, that's even worse. So maybe a GIF's not exactly what I want. So now if I want transparency, I can't use a JPEG because JPEG won't give me transparency. So I can go then with, obviously I'm left with a PNG. So PNG 8 is still not giving me the look that I want because I want this all the way transparent. I'm going to have to go with 24 because I've got actually a drop shadow on this, and so it's got to have nice smooth gradient edges. So now I'm looking at going from 193K in my original down to 77K in here, and I can adjust my image size, my output size. Remember, this is my pixel dimensions. This is how wide in pixels my image is going to be. So maybe I want to make it 200 pixels even. It shrinks it a little bit. Now I'm down to 65K. That's not bad. I really don't have a lot of options here. I can turn off transparency, but that's kind of the point of using a PNG is to have that transparency. And so that's pretty much all I can do. I'm kind of stuck with that file size, which isn't too bad. So I save it, I name it, and I put it in the folder. So that is image resolution in sort of a very quick nutshell. See you in class.